Hey guys, Zach here with Math Muscle. Lesson today on solving quadratic equations. Looking at this form here, for those of you who are new to the quadratic equation, this is a quadratic equation. And it's a quadratic because the leading term, the term with the highest power here, is a 2, considered the quadratic term. This is called the linear term, and this would be called the constant term, where a, b, and c are real numbers such that a is not equal to 0. Today we're going to be talking specifically about the case where b equals 0. We're going to talk about two different methods on how to solve a quadratic equation where b equals 0. So without any further delay, let's jump into a few examples. All right, guys, so if b is equal to 0, then really what we're going to be encountering here is ax squared plus c equals 0. What my goal and objectives are here is to determine values for x such that when I evaluate this side of the equation, I get 0 out. So it's a solution to this equation. Now, with regards to some mathematical terminology, some synonyms that you will encounter. When you have a situation where it's set equal to 0, you will be finding what we call the zeros. A synonym for that is the roots or solutions to that equation. Okay, so let's take an example here. Let's go with the equation, for example 1. Let's go with the equation x squared minus 16 is equal to 0. How would we solve for that? Now, b clearly here, there is no linear term, right? I don't see an x alone within the equation there. So what I'm going to do, or my first method in solving, is I'm just going to do, in this case, a two-step equation. I'm going to add 16 and take the square root. So if I add 16, I get this, and then I take the square root of both sides. Now, when you take the square root, you're going to get two answers. Right? You're going to get a positive value and a negative value. And we'll come up with up to a different example here soon where you'll see a conflict of interest with this. Now, if I were to take the square root of 16, that would be plus or minus 4. Therefore, the solutions to that equation, or the zeros, or the roots, is plus and minus 4. Let's look at another example here. Let's take the example 2x squared minus 18 is equal to 0. Okay, in this case, we're going to have to do a three-step equation. Last time we did 2 steps, but I'm going to do 2 steps in one. I'm going to add 18 and then divide by 2. So if I add 18 and divide by 2, I get x squared equals 9. When I take the square root of both sides, I would get plus or minus the square root of 9, which is 3. What you'll notice is that in situations where b equals 0, the two solutions, if they exist, if there's two solutions that exist, will always be equidistant from x equals 0. So they're the positive and negative values just in either direction. Okay, let's look at a third example. Our third example will be x squared minus 5x plus 10 is equal to negative 5x. Now, you might be saying, well, b doesn't equal 0 here. But what I need to do is get it in this form prior to doing any sort of two-step or three-step solution method. So I'm going to add 5x to both sides. That should be add 5x to both sides. And what you'll see happens is that the linear term disappears. Okay, now when I subtract the 10, so this is my second step, I'm going to subtract 10. Notice that we're going to have an issue, right? So when I take the square root of both sides, we have a major issue, and there should be bells and whistles going off here. I can never take a square root of a negative number. Therefore, in this case, there are no real solutions. No real solutions. Anytime you take the square root of a negative number, please beware. Okay, let's move on to the next slide here and do a few more examples. All right, so here we are with examples 4 and 5. If you're feeling comfortable with the topic, go ahead and attempt these on your own and then watch the remainder of the video. Okay, I'm going to go ahead and work through number 4. I'm going to add 42 to both sides. That gives me 3x squared equals 51. I'm going to divide both sides by 3, so I get x squared equals 17. Therefore, x will equal plus or minus the square root of 17. Now, the square root of 17 is not a number that is a perfect square. Therefore, I'm going to leave my answer just like that. Your teacher might require you to do some rounding, as that will be a decimal answer. Okay, number 5, let's try this problem as well. Subtracting 5, I get negative 4x squared is equal to 24. Dividing by negative 4, I get x squared equals negative 6. Right here, I'm going to stop. And I'm going to say no solutions, as I see what's coming. Okay, there's no real solution to that equation. And that's because I can't take the square root of a negative number. Okay, another method that can be used to solve these is a method called the difference of squares. I'm going to cover that here on the next few examples on the next slide. Okay, so the difference of squares is a method that's used when b equals 0. Okay, and how it's used is somewhat of a method of factoring. You can solve both of these questions using the methods shown in examples 1 through 5. However, when you recognize this and get good at it, you can use this factoring method as well. So this is called the difference. I'm not going to write it all out, but the difference of squares. Okay, so how it works is I take this first term, x squared, and I take the second term, 49. And as long as it's the difference of those two terms, so x squared minus something squared, or in the second example, number 7 here, 4x squared minus some other number, I can take the square root of both of those and write it in factored form. You can confirm this algebraically. I have now factored that expression. Now look here, the square root of x squared is x, the square root of 49 is 7, and because it's the difference of two squares, I have to have a plus and a minus. What happens is our linear term disappears. If you were to FOIL this out, you'd get a positive 7x and you'd get a negative 7x, which means there'd be 0 x's, and 7 times negative 7 is negative 49. Now, if I were to tell you that a times b equaled 0, you could say either a equals 0 or you could say that b equals 0. In our case here, since x plus 7 times x minus 7 equals 0, either x plus 7 is equal to 0 or x minus 7 is equal to 0. Therefore, x has to either equal negative 7 or x equals a positive 7. The same answers we would have gotten if we would have added 49 and then taken the square root. So those would be the solutions to that quadratic equation. Let's use the same method in example 7. What is the square root of 4x squared? Well, that would be 2x. What is the square root of 81? That would be 9. And again, I go plus and minus. It doesn't matter the order in which you do that. Therefore, 2x plus 9 has to either equal 0 or 2x minus 9 equals 0. That yields us answers of x equals negative 9 halves or x equals positive 9 halves. Okay, so we've covered a couple different methods for solving, finding the solutions, the roots, the zeros of the quadratic equations. Okay, hope it went well. Building some math along the way. Muscle videos to come. Have a great day. See you in the next video.